Alright, welcome to another AQA A-level chemistry video. Today I'm going to be making a video on organic synthesis. So this topic you don't have to necessarily know, like there's not going to be questions directly about, or yes, technically there would be some questions about organic synthesis, but this in itself isn't like a topic that you think of as in like this specific points or like it's a part of the unit. It's more something that can apply to anything in organic chemistry, and really it's just making you understand, like for example you might get a 5-mark question where they want you to explain a practical, the how to minimize, how to make the reaction more efficient, how to reduce waste products. And really when it's asking you that, it's just asking you about how to make the synthesis of the the synthesis of the reaction more efficient, right? And that's includes things like how to minimize risk. And these are things, basically what I'm trying to get to here is everything that you could think about when you're writing down all the points, all these points that you could think about when you're writing your 5-mark question. You need to say specific points. So things like just saying they can do the reaction in less steps to reduce waste products, or use a less volatile solvent. Things that you just think about whilst you're before you actually do your reaction. So these things that every scientist does this before they actually do a reaction. You do it as well if you've ever done a practical. You've planned out your practical about how you want to do it, and what steps you want to do it, so that you can minimize waste products, and also maintain safety as well. So, and in your and it's the same principle when you're actually answering questions. They might ask you questions related to practical skills, and actually planning out and saying why you've done that and when you've planned it out is actually quite important. It's an important part. They might have, they might emphasis that they might try to so one of the marking points might be if you do this, if you do it in less steps, you could increase your percentage yield because you have less waste products, so your percentage yield will be much higher. Things like that. It's just about it's just about explaining the points or memorizing some of the points that would be relevant to you actually answering the question. All right. Or like gaining the most marks. I'm actually gonna shut up now and actually go through the topic. So, introduction to synthesis. So, for organic synthesis, chemists must map out a route of reaction that will lead to the desired product and start from the starting materials. Organic synthesis. So, if we synthesize a molecule, we must find reaction routes that will allow us to convert starting materials into the desired product. After finding possible synthesis routes, we must make sure the route is the best it can be by considering the effect on the environment, the type of solvent used, percentage yield, and percentage atom economy. So synthesis in steps in synthesis, right? So I just got a little X, Y to Z here. For example, if we could skip out the Y process, that would be, ideally we want to make our reactions as short as possible, unless if we just want to get to a certain point, we want to make our reactions as short as possible. So if this reaction is going from X to Y to Z, we have to think about ways. Is there a way we can do this so we just go from, or is there another reaction that would go from X to Z? And if so, if there is another reaction that would go to X to Z, would be more costly? Would it be more would it be more costly? Would its percentage will be lower? Would the percentage of atom economy be lower? How would it affect the environment? Type of solvent use, would it just have toxic solvent use? So and if no, then you can say it doesn't have all those things, and it has and the reaction route is less. Okay, then go for that route. However, if the reaction route is shorter, but it has, you know, a lower percentage yield, a low percentage atom economy, and things like that, then you're better off just going through this route, even though it has this little intermediate stage here. And that's all I'm just trying to get to. You guys probably know this, but it's just about being able to explain this, being able to weigh up in your exam, be able to say this reaction. That's in their exam, right? I know I'm kind of stuttering too much and going over it, but really in the exam, I've seen questions where they ask you to say which reaction route is better. And it's particularly the case when you're talking about making amines, where there's like the way by nucleophilic substitution, or the way by reducing a nitrile. and you explain both points. You explain why it's better to do it this way, and go through that. I'm not gonna go. If you want to know more about that topic, then I'll leave a link in the description to basicity and nucleophilicity. But here, all I'm trying to get used here is just to understand how to make the reaction as efficient as possible and understand organic synthesis. So each synthetic route is made up of a series of reaction steps. Each reaction step typically involves carrying out the reaction, separating the desired product, and purifying the desired product. All right, so I'm pretty sure it's pretty self-explanatory. So just thinking about, for example, with crystallization, we pat down. If we want to make sure that we don't include the impurity of water, right, when we're crystallizing, we'd at the end of it we'd pat down our dry crystals, with or we call it blot down with a dry with dry paper or filter. It's usually with filter paper. Usually we use the filter paper to kind of blot it dry, and that's to make sure we're weighing an accurate amount of our product, and we don't include we don't include any of the we don't include the mass of the water as well. There's probably better examples, like for example, purifying the product, like using a buck in the funnel, right? Because there's other ways. There's other ways of instead of using that process of blotting down with a hand towel, which you still do, but it's not as effective as using a buck in the funnel that uses pressure to allow air to pass through and make sure that the crystals will be dry. That would be a much better way of doing it. So not just the actual route, but the equipment that you would use and how you would use it that would affect your organic synthesis. So it's important. Right? So creating synthetic routes is incredibly important in science. It helps us design and produce medicines. It also helps us reduce the waste and hazards whilst producing such chemicals. So improving synthesis, right? There are many ways to improve synthetic pathways. This involves maximizing the desired products and minimizing the side products. So everyone knows percentage yield is equal to actual yield over the free radical yield times by 100. But doing these calculations are important. Why? Because doing it before you actually done your reaction allows you to let you know how efficient is this actual reaction, how much of my product am I actually getting out of this, instead of wasting time doing the practical and then you find out later on, oh, you're not actually getting a lot. So this is all part of the preparation stage. So I know you're going to think, why am I just mentioning this for no reason? It's about if they ever ask you why the percentage yield is important, it lets you know beforehand how much of your product you're getting from the reaction before you actually even do the reaction. How it's done, they usually get a small sample before they actually do big batches. Yeah, I'll leave it at that. Performance of a synthesis. So the percentage return is the percentage ratio of the actual yield obtained to the calculated theoretical yield. Maximizing percentages. So we can optimize the percentage yield and the atom economy by selecting reactions without byproducts, selecting synthetic routes with fewer steps. And in summary, if I'm going to go back to improving synthesis, right? As I said before, there's many ways to improve a synthetic pathway. This involves maximizing the desired products and minimizing desired products just here. So the main thing is we want to out of every reaction. I'm just cut there for some reason. I was trying to say that from every reaction, we're trying to minimize the amount of product that we use. Trying to make, ideally, we're trying to say minimize byproducts. Obviously, no. We're trying to minimize the reactants we use and maximize the product. I.e., what that means is we're trying to make the very most out of the very little that we have, and that's what we're trying to do here. So we don't want to use a lot of a compound to make only a small amount. That's not efficient, unless it's a very rare and specific compound. Then that's fine. But ideally, out of most reactions, we want to make the very most out of very little. So, and I think, and then I'm not sure I understand. You wouldn't understand, Siri, would you? But there's many ways to improve a synthetic pathway. This involves maximizing the desired products and minimizing desired products. So if you can do that by so you can make the most out of your products by maximizing. So sorry, you can make the most out of a reaction by maximizing the desired product and minimizing any byproducts. And you can minimize byproducts by taking down a few steps. If you can do the reaction in less steps, that would be the most useful. Now that's it really. That is the essence of the video. Yeah, that'll be it.